A chatbot can talk. It can answer questions, explain ideas, help you write a sentence, but it cannot do anything. It cannot open a file, run a search, send a message, or check a number. It just sits there and produces text, and for a lot of tasks, that is fine. But the moment you want an AI that can actually act in the world, not just describe what it would do, but go ahead and do it, you hit a wall. The wall is that the model itself has no hands. It lives inside a conversation. It does not have access to your computer, your database, your calendar, or anything else. So how do you give it hands? That is the whole subject of this video. The idea that makes it possible is called function calling. And once you understand how it actually works, you will understand what an AI agent really is, why it behaves the way it does, and how to build one that is actually useful instead of just impressive in a demo. What is function calling exactly? Before we get into building anything, let me explain what function calling actually is in plain terms, because the name is a little misleading. It sounds like the model is running code. It is not. The model does not execute anything. Here is what is really happening. You describe a set of tools to the model in plain language. A tool is just a function your code knows how to run. You tell the model what the tool is called, what it does, and what inputs it needs. The model reads those descriptions and keeps them in mind during the conversation. Then, when the model decides a tool is useful, it does not call the function itself. It replies with a structured message that says, I would like to call this tool with these inputs. Your code receives that message, calls the actual function, gets the result, and sends it back to the model as the next part of the conversation. The model then reads the result and decides what to do next. That is the whole mechanism. The model is never executing code. It is requesting that your code run something and then reading the answer. All the actual work happens on your side. This distinction matters more than it might seem, because it means you are always in control of what actually runs. The model can only request. Your code decides whether to honor that request, and that is where all your safety logic lives. Why this one idea unlocks so much? That simple mechanism is the thing that turns a chatbot into an agent. Once the model can request that your code run something and see the result, you can wire in anything your code can do. You can give it access to a search engine, a database, a file system, an API, a calendar, a calculator, anything you can write a function for. The model does not need to know how any of those things work internally. It just needs a clear description of what each tool does and what it returns. And then it can use them to work through problems that would be completely impossible for a pure text response. The key insight is that the loop between model and tool can run multiple times. The model makes a call, reads the result, decides to make another call, reads that result, and keeps going until it has enough to give you a final answer. That looping behavior is what people mean when they talk about an agent. It is not a single call and response. It is a system that can take a sequence of actions over time. Building a small agent conceptually. Let me make this concrete with a simple example. Say you want an agent that can answer questions about your own files. The most basic version of that would need two tools. One that can list the files in a folder and one that can read the contents of a specific file. You write those two functions, you describe them to the model, and you set up the loop. A user asks a question. The model receives the question, along with the tool descriptions. The model decides it needs to look at what files exist. It replies with a request to call the list files tool. Your code runs it and returns the list. The model reads the list and picks a file that looks relevant. It requests the read file tool with that file name. Your code reads the file and returns the contents. The model reads the contents and now has enough information to answer the original question. That whole sequence is an agent, not a complicated one, but a real one. It decided what to do, used the tool, used the second tool, and produced an answer it could not have produced without them. And you built it with two functions and a loop. Let me walk through the loop more carefully because understanding it clearly matters when things go wrong. The loop has 4 steps that repeat. Step 1. The model looks at the current state of the conversation, including any tool results from previous iterations, and decides what to do. Step 2. If it wants to use a tool, it replies with a tool call request, not a final answer. Step 3. Your code runs the tool and adds the result to the conversation as a new message. Step 4. The loop goes back to step 1. This repeats until the model decides it has enough information and produces a final response with no tool call in it. That final response is what the user sees. Everything in between, all the tool calls and results, is internal scaffolding. The user usually never sees it. This is why agents can feel like magic from the outside. The user asks one question and the agent does 5 things behind the scenes before answering. But from a code perspective, it is just a while loop. Keep running until the model stops requesting tools. Send assigning good tools. Now, the quality of an agent depends enormously on the quality of the tools you give it. And the single most important rule for designing tools is to keep each one narrow and specific. Do not give the model one giant tool that does a bunch of things depending on what arguments you pass. Give it 5 small tools, each of which does exactly one thing clearly. The model reads the description and decides which tool to use. If the description is vague or the tool does too many things, the model will make bad decisions about when and how to use it. A tool called search that searches files or the web or your database depending on a mode parameter is a disaster. 3 tools called search files, search web, and search database are clean and predictable. Naming and description matter more than you probably expect. I have seen agents dramatically improve just from rewriting tool descriptions to be more precise. The model is reading those descriptions to make decisions. Treat them like instructions, not just labels. Just repeat make intent. The second thing about tools is that the output they return should be readable and actionable. The model has to make decisions based on what a tool returns. If you return raw database rows with cryptic field names, the model will struggle to interpret them. If you return clean, plainly labeled information, the model does its job better. Think of every tool return as a message to the model. Make it clear. And on the input side, design your tools so they are safe by default. A tool that reads something is safe. A tool that writes, deletes, sends, or changes something carries real risk. The model is going to code that tool based on the natural language request, which means there is room for misinterpretation. The solution is not to avoid right tools. It is to be deliberate about when you include them and how you constrain them. The guardrails that actually matter. So let me be specific about the guardrails that matter in practice, because I see a lot of people skip this. The most important one is this. If a tool does something that cannot be undone, add a confirmation step before it runs. Do not let the agent send an email, delete a record, or publish something without a human in the loop. The pattern is simple. When the model requests a destructive tool call, instead of running it immediately, surface the request to the user. Say something like, the agent wants to delete these 3 records. Confirm yes or no, and only run the tool on yes. This feels like extra friction, but it is the thing that lets you actually trust the system. The second guardrail is to always read what the agent did. Log every tool call and every result, not just for debugging, but as a habit. When things go wrong, and they will, you want a clear record of exactly what the agent called and what came back. Tools can behave unexpectedly. An agent that ran quietly and left no trace is an agent you cannot diagnose or correct. I keep a simple log next to every agent I run. It records the tool name, the inputs, the output, and a timestamp. It takes almost no code to set up and has saved me hours of guessing when something produced the wrong result. You cannot build trust in a system you cannot inspect, where agents genuinely shine. With those basics in place, where do agents actually shine? In my experience, the answer is boring multi-step chores. The tasks where you know exactly what needs to happen, where each step has a clear checkable result, and where the only reason it takes time is that there are a lot of small moves. Things like pulling data from 3 different places and combining them into a report, renaming and organizing a batch of files based on their contents, running through a list of items and applying the same check to each one, checking a set of conditions and flagging the ones that fail. These are tasks where a human is mostly just following a procedure, and the interesting judgment calls are rare. Agents are very good at procedure. They follow the loop, call the tools in the right order, and produce results that are usually easy to check at the end. The boring stuff is where they earn their keep, where agents genuinely flay you, and here is the honest counterweight. Agents are genuinely bad at open-ended goals where the definition of done is unclear. If you give an agent a task that requires real judgment that changes depending on context, or that has no clear stopping condition, it will often spin, take wrong turns, or hallucinate a done state that is not actually done. They also flail at anything that requires understanding of consequences outside the immediate task. An agent optimizing a SQL query might optimize it correctly and break something downstream it did not know existed. Agents do not naturally have situational awareness the way a person does. They see the conversation and the tool results and nothing else. So the constraint is not that agents are dumb. is that they are operating with limited visibility. The narrower and more defined the task, the better they do. The broader and more open-ended, the worse. This is not a flaw to work around. It's just the shape of the tool. Not every task needs an agent. A related mistake I see often is using an agent when a single direct call would do. If you know exactly what you need, write the code that does it. An agent is the right choice when the sequence of steps cannot be fully specified in advance, when the model needs to make decisions based on what it finds at each step. If you already know the steps, skip the agent. This might sound obvious, but it is very easy to reach for an agent pattern because it feels powerful and end up with something more complicated and less reliable than a plain function call. The power of agents is precisely the adaptability. If you do not need adaptability, you do not need an agent. A single well-prompted model call with no tools at all will outperform a sloppy agent on most tasks that are really just about producing good text. Save the agent for the tasks where the environment is variable and the path cannot be written in advance. What I would tell a builder starting out, if I were giving someone advice on building their first real agent, I would say this. Start with 2 tools and a tight loop. Pick 2 tools that do things your code can already do. Keep the task narrow and the definition of done clear. Wire up logging from day 1 so you can see every call and result. Run it, watch it, read the logs, and understand what the model is actually deciding before you add anything else. The temptation is to wire in 10 tools from the start and give the agent a big goal. But what that produces is a system that does things you did not expect and is very hard to debug when it goes wrong. 2 tools and a tight loop teaches you the model's decision patterns. It teaches you how to write tool descriptions. It shows you where the loop breaks down and where it works cleanly. And almost every useful agent I have built started from something that small and grew from there once I understood the behavior. Do not start with the impressive version. Start with the version you can read. There is a lot more to the agent space: tool schemas, error handling, multi-agent setups, memory outside the context window, all of that. But the foundation is the thing I laid out here. A model that can request your code to act, a loop that keeps running until the job is done, tools that are narrow and safe, and the habit of reading what actually happened. If you have that in place, everything else is an extension. Subscribe and follow along. Thanks for watching, and I will see you in the next one.